morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the DB2Night show, and this is show number Z118. We've done 118 Z shows for the DB2 community, and we're all pleased to see you here today. We've done over 200 DB2 LUW shows, so after 12 years, we've provided quite a bit of content to our community, and we're pleased today to have back with us Tony Andrews, senior instructor with Themis, and I believe you said you've been an IBM Champion now for 10 years, or is that about right?
Yeah, maybe about 11 years, I think now.
Well, I didn't want to shortchange you there. I was a champion since 2008, and they came by and made me a lifetime champion. So all I got to do is keep living, and I'll be a lifetime champion. And but it's great to have you here again. You always provide great information to our community. We're grateful for that. So let me run through and get the pleasantries out of the way and the formalities, and we get on to your great presentation. As always, here's our social media page. Most important things to note here, as always, are the Twitter, because if you subscribe to the hashtag DB2Night, you'll get updates on upcoming shows and when replays are available. And we also now put our replays on YouTube, so when I finish the YouTube stuff, I tweet about it, and you'll be able to watch the show there if you don't want to download it, or you can continue to download it and get the PDF as well on our replay blog. There's our disclaimer, copyright, trademarks. We love them all. We respect them all, and all that type of stuff. So here we go. And DBI is our founding sponsor of the DB2Night show, and we're grateful for the use of their GoToWebinar software and the support that they provide to the DB2Night show and the DB2 community. So here's our quick announcements. We're into replay mode. This is the last show of the summer. You can imagine me out on my patio sitting in the rain waiting for it to warm up so I can go swimming in the pool, because that's what I'll be doing again this summer. We're not going anywhere until all of these vaccines are out in the general public. I've got my second shot, and in about 12 days I should be good to go, but I can't imagine anyone going in public in the Toronto area where I live without a mask on. It's just how we do it up here. If you have any ideas, please, for speakers and topics that you'd like to hear in our upcoming seasons, please send a note to the DB2Night show hosts, or put it on your comment format at the end of the session where we ask for feedback. I'm interested in doing the right things for our studio, for our attendees and the community. And as always, there's a link to a DBI seminar on their products available there from their website. And if you do that, you get I believe they give away a Starbucks gift card or some sort of gift card if you watch the demo. I'm not sure I got that name right. I apologize. I did mean to fill that in. That might be the one before. Apologize if I was going through and making my updates today, and I just had a feeling I was forgetting some things. That might be it. Our sponsors are DBI and yours truly. Now we're into the studio audience polling. These are fairly generic today, but that's okay. We like to see what people are doing. Our first one is, what version of DB2Z are you running? I broke up the version 12 to various levels here. People stay current. Certain things are scaring people, such as getting rid of old segmented table spaces. Oh my goodness, you have to do conversions of stuff. It always gets a little scary, because the more data you have, the more you depend on this stuff, right, Tony?
Yeah. Hey, Martin, it will not take any selection from my end here.
Oh, you're a panelist. You don't get to vote.
Okay.
But I'll show you what our audience said. We've got some people new, some people on to version 12, and some people still on version 11. We'll which of the following commercial databases do you use? Of course, with our fine-looking audience, we're going to get some DB2 responses, I sure hope. And if there's anyone else ticking around with other things. Of course, we've got the collector series of databases out there, so everybody has to run something. We'll share the results there. You get sort of right across the board there in terms of commercial stuff. The next one is which open source stuff. There's some people are getting more and more into open source. And, some of my old friends from the IBM Toronto lab are off doing anything from Snowflake to Cockroach DB now. I should be updating my list with all this new stuff that's coming along. It's hard to keep up with it all. Have you ever seen anybody running all this new stuff, Tony? Cockroach and Snowflake? Snowflake,
yes.
Good.
Big project going on at a bank that I'm doing some work for right now, coming up where they're moving a lot of stuff into Snowflake.
Well, we better not talk about it too much because we're a DB2 show after all. But of the ones I had listed, we've got Mongo and MySQL showing up. Hide that, move along. And how, just getting an idea of how experienced our audience is. And we're finding there's more and more people with a lot of experience in here. Looking at this one, we find there's an awful lot of people with 30 years experience. I started with DB2 on Z, and it was back when I was doing it was MDS 370. We didn't even have XA when we first went to DB2 1.1. That was in 1985. Finding that people that are voting today are very senior people. But of course, one thing when you talk about performance and optimization, one thing I've learned is there's always something more to know. Is there a role on our audience here? It's the standard old question we have. As is typical, we have mostly DBAs and system programmers or admins or other people like that. That's our audience today. Thanks all for voting. That takes us through that. Now we'll move over and whoops, went by too quick. There's your picture, Tony. I'll click on you and you should have your link coming up. Now we just wait.
All right.
Take control, and it's all up to you.
Show my screen.
Good idea.
All right, thanks, Martin.
Thank you.
Thanks for organizing this all the time. These Friday shows are always very informative. So thanks for the invite to come and speak again.
We're always happy to have you.
I'm more than glad. And hopefully I'll see you here sometime later this year, somewhere out there, I hope.
Yes, the invites are out for Edinburgh, and I'm kind of on the fence. I'm not sure whether or not I'm going to spring to go over there because we're just not sure what's going on. Now, as always, I'll be watching the question queue. I'll be muting myself so you don't get any background noises. Our dog's too old to bark, but I'll be here and jump in as need be.
Okay. Good morning, afternoon, everybody. As Martin and everybody knows, Tony Andrews, FamousInc.com. So many of you might know me. Do a lot of training, do a lot of consulting, more training than consulting. And you know, from my end, I guess you can kind of call it my gig is mostly on the application side. I grew up as a developer, mainframe, COBOL developer, and continued on in development over the years, and loved the developer side. And application DBA at times on some projects, but I never really went fully into the DBA role, although I had opportunities. I just really liked the developer side. And as I moved on into some really big projects years ago, about anything you can think of to DB2, you know, Cores vSAM to DB2 and Datacom to DB2 and IMS to DB2, and you know, just started getting pretty good at this stuff and pretty strong in SQL programming. And then, of course, the more you code and test, the more you get into some performance issues. So most all of my talks that I do at the IDUG conferences and the regional user groups and things like this typically revolve around the developer side. And I've been on a big push for many years to try to get more developers, more proactive in doing explains and understanding optimization, because it just empowers them more to do a better job. And I've actually been able in some companies to kind of convince them to, no, we need to get this explains rolled out to everybody, and we need to build in some time to have them do some explains, and they at least need to know some of the basics. And that's kind of where I come from, because in most all of my performance and tuning engagements and even projects when we coded and were like, you know, working on testing, I would probably say 85% of the time when I was able to get things to run faster, I never left the application side. I didn't talk to a DBA, I didn't talk to a systems programmer, I didn't talk to anybody. We looked and we monitored and we changed code. And that just opened my eyes many years ago. You know? And so when version 9 came out, you know, there was a lot of great things there, and then 10, 11, and 12. A lot of things on the optimization side. You know, everybody's you know, heard some of the IBMers, Terry Purcell especially, talk about a lot of these optimization features, and some of them from the application side I found like really good and really helpful. And not that they all weren't helpful, but that's what I'm going to touch on today. Just some of the things that is really good in today's world, that these things are out there, and some things that you know, if people are doing explains, you know, what they should, you know, some new stuff that they might see and wonder, what is that? What does that code mean? What does that mean? What's going on here? And we'll talk about that a little bit today. Okay, so a little bit of the agenda. Does the optimizer actually rewrite some coded predicates? At times, yes, it does. Rewrite our predicates, we'll add some predicates, you know, into our query at times. And if you're not familiar with that or don't know that, that sometimes can confuse you if you're looking at some explain output. Does the optimizer actually rewrite the query? Yes, at times, especially with our subqueries. And this is something that I really stress in SQL classes and even in advanced SQL classes, and stress to developers. You need to get stronger in SQL programming. Sometimes there's 4, 5, 6 different ways to write a query to get the same result set back. Now, why is that important? Because out of 4, 5, or 6 different ways, you may get 4, 5, or 6 different optimization paths. If you get 4, 5, or 6 different optimization paths, you're going to get 4, 5, or 6 different run times. So one of them is going to run faster than the others. And from my experience, that's pretty much what I do. So to be really good, I think, at performance and tuning in applications, you need to be really strong in SQL. The optimizer does rewrite some of our queries, and we'll see some examples of that coming up. And we're just going to look at some of the optimization features, you know, through these versions that I think are kind of important to like touch on, and just some terminology that'll come up in the presentation: transitive closure, safe query optimization, filter factors, global query optimization, safe query optimization again, SQL pagination, you know, some other kind of terms that I'll touch on, and maybe some of you have heard. Okay, version 9, a little phrase that came up, correlate, decorrelate. One of the things that I always drove into developers that I worked with on projects is all you developers should know how to take a non-correlated subquery and write it as a correlated subquery. Or take a two-table join and sometimes take a table, if we're not pulling columns from it, move it down and do a subquery. Or take a subquery here and move it into a two-table join. If I'm looking for exists logic, where some primary key exists in another table, there's actually 4 different ways to code that in SQL. If you're looking for not exists, there's 4 different ways you can code that in SQL now. You can take any in subquery and rewrite it as an exist. Any exist subquery, rewrite it as an in. And as we did walkthroughs for many years on projects, if a query came in like this, I would ask the developer, hey, have you tried this as an exist? And then if they had not, then we were not going to go to production with it, because I wanted to see the run times between the 2 different ways, and even a runtime with the 2-table joins. You just have to watch when you move it into a 2-table join. If there's a one-to-many relationship in the tables, you're going to get duplicates back, and you're going to have to handle the duplicates. When you move a table down into the subquery and you say is a value in that list, or does this join condition exist in that other table, you're not going to get the duplicates. Okay, so you just kind of have to watch out for that. So that being said, when version 9 came along, it was taking some of our subqueries and actually taking a non-correlated and the optimizer code, rewriting as a correlated and costing them out. So here's an example here. The examples are based on our sample tables in DB2. So here's an in, just a simple in. Give me the employees or their employee numbers in this list of employees from this other table, based on this condition here. Okay. And you can see as we look at the plan table explain output, it is a non-correlated subquery. Non-correlated, there is no join in that subquery. Correlated subqueries have a join down there, and they work extremely different from each other. Okay, I could take this, I could rewrite this as an exist. Okay, so you can see the output of this, we get 2 rows back. Now the key here is down in that emp proj activity table, the table that's referenced in the subquery, that actually an employee like employee number 140 could be down there multiple times, and actually is down there multiple times for that project. It's an activity table. So if I'm working on that particular project, I may be down there 3 or 4 or 5 rows, because I work on different activities of that project. Maybe I do coding and testing and documentation and whatever all the activities are. Okay. Now, the other thing I want to point out here is in the explain output, you can see this table name here, DSN WFQB02. And we're starting to see that a little bit more and more with the in subqueries, where if the list is going to go past a certain threshold of values, instead of just building the in list as it has always done, it puts that list of values into a work file. And that is a data set work file specific to Q block number 2. Okay, each select in your query gets a what's called a query block number, and they're numbered from like the top to the bottom. So the outer select up here, this select is query block 1. The next select in there, it happens to be the subquery, that's query block number 2. Now, that's not the order of which they get executed. This subquery's got to execute first in order to fulfill that predicate logic for the outer query to go and execute. Okay. So it decided to take this data and put it into a work file, and then that work file feeds the outer table in a nested loop join. Very interesting, as opposed to just building an in list and executing the outer query based on either a table scan or maybe an index on the employee number. Okay. Here we rewrite that as an exist subquery. So same exact logic, okay? Same exact rows are going to come back, but we have the join predicate down here. This is a correlated subquery, so we have a join a reference from this table in this subquery to a table in the outer query. Now you can get nested in subqueries and have a 2 or 3 deep subquery correlate back to one of the previous subqueries or all the way back to the outer query. Okay. And when we look at the output of this, look what the query block type is: non-correlated subquery. This is the exact same explain output as the screen before. So what the optimizer did is it took this exist subquery here and it rewrote it as a non-correlated subquery. Did the same thing that a developer should do. Okay. Now, does that mean developers should not continue to do this? No, it doesn't, because it doesn't hit all the different conditions yet in the optimizer code. For example, if I take a non-correlated and it converts it to a correlated subquery, I can go back and code up a correlated subquery, and I've seen the optimizer many times change that into a join. But you go, wait a minute. So if I start with a non-correlated, the optimizer changes it to a correlated. If I give it a correlated, it changes it into a join. Well, why didn't it take my non-correlated and then work its way right into the join? Well, it doesn't do that now. It's just kind of one simple step at a time. So we as developers should still rewrite these, the different ways. But know that sometimes when you go look at and explain, you may see a different query block type than what was actually coded. That's the part I want to point out here. Okay. Okay, transitive closure. This is a phrase that's been around really forever in DB2, and it has to do when we're doing joins, when we're joining a column in one table to a column in another table, and it also comes into play when I'm comparing a column in a row to another column in the row. Is my salary equal to my bonus, for example? So I'm comparing a column to a column. So let's take a look at this. Here's an example here where a column is being compared to another column in the row. So if the administrative department column has to be A00, and we're saying it has to equal the department number, well, the department number has to equal A00. So the optimizer adds that in there, does the transitive closure on that. And it really has done this for years with the equal predicate, and it hasn't done it for years with other types of predicates that we'll talk about here in a minute. So why would it do this? I mean, why did it even do this 30 years ago? Because what drives the use of indexes mostly is our where logic. What are the columns being used in our where clause? And the optimizer code takes those columns and goes and compares it to what the indexes are. And what are the leading columns of the indexes? That's why it's so important for developers to make sure they code their predicates in what's called an indexable way. There's a lot of ways you can code where logic that makes that a non-indexable predicate. Each one of these statements is called a predicate. We don't want non-indexable predicates going into production. Because why? Because we don't really want to take 99.9%. We don't want to take an index away from the optimizer to cost out. Sometimes people will look at an explain and go, this explain looks perfectly fine. It's using an index, but it's just not coming back as fast as we would like. And when we look at their code, they have some predicates coded in such a way that the other indexes were not even being evaluated. And once we rewrote those, we saw it move to another index and we saw some speed pickup. So again, we're back to code. We're back to like changing things. So it adds this other predicate here. Now it's going to look and see, do I have an index on administrative department? Do I have an index on department number? Hey, I got an index on both of them. Now let's cost them out and figure out which one I want to use. So where this can get a little confusing is you may look at a query like this and the administrative department equals a value. But the index that was chosen is based on the department number. And when you look further into that, you see that there's a matching column and a nice probing, through that index file. Like, wow, I don't even have a where clause on that department number column, but yet it's probing that in a matching, condition. Could be a little confusing. So these are some of the things that I like to kind of point out to a lot of developers that haven't done a lot of explains, and they're getting into explains, or they want to know more about this, because things like this can be confusing. Now, once we got up into like version 10 and version 11, we see that the transitive closure will take place on just about every type of predicate. Okay, so we saw it on the equal predicate. That's been around forever. Okay, then the in predicate was added in version 10. Then the range predicates were added, with the greater thans and the betweens, and the subquery predicates were added. And actually, all predicate types right now are going to get the transitive closure except the like predicate. So if I go back here, if I had this and I said we're administrative department like A%, this will not get added over here. I don't know why they haven't done that yet. I brought that up to Terry and some others at some of the IDUG conferences. Like, hey, come on, you guys, you went in, you did the range predicates, the in predicates, the subquery predicates. Why could you not do the like predicates? Didn't have a real good answer for that, but that's the way it is. So if we're doing any kind of like, then it's up to the developer to do their own transitive closure on the query. Sometimes we get into some pagination kind of logic, where we scroll, through a number of screens, or scroll through some data, whatever our last row is. We want to get things, the next group of rows that's all greater than that last row. And for many queries, developers out here will code things like this. If we have a we have a search screen that's showing last name, first name, middle initial. We have so many per screen, and they want to go get the next 20, to show. This is a type of a query that was coded and still is coded some today, because this is the way the developers like, oh, okay, well, I get the logic. Here's what I need to code. And when you have a lot of OR logic, we lose efficiencies. Okay, sometimes we'll have enough OR logics that will just the optimizer just say, I'm just going to do a table scan. And there's way too many conditions there, okay? Or it will use multi-index, okay, with OR logic often, okay, which is pretty good, but is it the best thing that we could do? Maybe in a situation like this, it might have been the best thing we could do, unless we did something like this. And I have done this in many companies, and have showed this to many developers. That says, look, now we have two predicates that are anded together, versus the screen before, three predicates that are ORed together. Okay, and what we see when we move to pagination like this, we would most likely see the index being chosen, single index access, starting with last name. The last name's got to be greater than or equal to Smith. Let's get into the index quickly to that point, and let's check these other conditions. And this in my experience always outperformed this previous screen here. Okay. Okay, so now when we code these up, and we look at the explain output, if I had, let me go back here. If I had this one here that had the conditions ORed together, we see this range list, this access type of NR. So this is a very efficient thing going on with the optimizer here, where it's taken these conditions. It's going to start with the 3 conditions and see what it can meet, and then there's 2 conditions, and then the 1 condition to see what it can meet in the index to fulfill the 20 rows that we need. Okay, so we see this NR, and you see the matching columns over here, 3 and the 2 and the 1. Now keep in mind, the more we match on columns of an index, the faster our probing of that index and our response time is going to be. Okay, if I have a 6-column index and I'm only matching on the first column of that index, depending on the cardinality of that first column, you may not get all that great a response time. But you look at the explain output and you say, hey, it's using an index and I'm matching on a column. What's the problem? You know, and maybe you have the third and fourth and fifth columns coded in your where logic also. But if they're not the first, second, third, and fourth, that's where we start getting all the matching. If I have the first one and then the fourth, fifth, and sixth, the fourth, fifth, and sixth become what's called screening predicates. And there could be, depending on your data, there could be a lot of screening once it hit that first condition, and then I had to screen through everything to look at all the other conditions. So the point being, the more you match on in general explain output analysis, the faster you're going to probe that index. So that's the NR. That's a really good thing. That's been a big improvement. Now, as far as SQL coding, we can come in here and just code it like this now. Okay, for last name, comma, first name, comma, middle initials greater than the 3 values. We don't have to have all that OR logic in there. Okay, order by, fetch first. Also in SQL, now you can do an offset and you can do a fetch first. This might come in handy for what people are trying to get after. You know, you have a whole result set, but I want to offset the first 20 or 40 or 60 or 80 rows and then pick up from there. The nice thing about SQL anymore, there was a version 9, 10, 11, and 12 brought about so much really good SQL coding for developers or anybody, analysts, you know, anybody that's writing a lot of SQL. We can put a select statement just about anywhere in SQL anymore. You have a select in a select, you have a select in a from, you have a select in a where, you have a select in a group by logic, you have select in a common table expression. You know, we have selects anywhere, and all those selects can have this type of logic. Offset, fetch first, order bys. You know, we used to be able to put SQL or in the select in some places in SQL, but we couldn't put an order by, or I couldn't put the fetch first. That provides a lot of power to me in writing up my queries and coming up with some logic. Okay, this is called a row value expression, by the way. Okay, there's another access type called in. Okay, then this goes back to the first example I was kind of showing earlier, where it takes the in list and it puts it into a work file, and you'll see the work file name in your explain output. Either you see the work file in the visual explain, or you'll see that DSN, you know, WF, QB kind of crazy table name in your plan table output. Okay, so does it always put these into a work file anymore? No. I mean, sometimes if it's a subquery, it will still build the in list. Sometimes the in list stays as the in list. Sometimes the in list goes into a work file. Okay, and you'll see that by an access type of IN versus the access type of N. Access type of N says I'm going to use an index based on my in predicate. Okay, IN says I'm going to put these into a work file, and then I'm going to nested loop join them to the table. So this can be a little confusing, where you might see a query like this, and you go and you run some kind of explain, whatever explain tool you're using, and you see nested loop join. Yeah, nested loop join. What's going on here? There's no join logic in there whatsoever. Kind of have to know a little bit behind the scenes of what's happening here. And again, with this list will be put in order, and if there's any duplicates in there, the duplicates will get dropped out. Just like when the subquery builds the in list, it will do a quick little sort and put them in order and drop out any duplicates. And here's the way it looks coming out of the plan table, which is really the one table that's been around forever in DB2 on the mainframe. And you see the table name here with the access type of IN. Okay. Now, another nice thing that came out is when we had two predicates in the past, a predicate on the first column of the index and a predicate on the second column of the index, and both of them were in predicates, we would only match on one column. Okay, we'd get a list of values for the first column, we'd get a list of values for the second column, but it would only match on the first column. Well, that's changed now. So we're going to see when you have two in predicates on the first two columns of an index, DB2 is going to put these values in some work files, and it's going to come up with the combinations to go attack the index with a 2-column attack. So you can see here, prior to version 10, this would come up with 1 matching column. Now, when we see this, we see a couple of different table names, a data set name based on the in predicate, number 3. And we see over here a method 1 for nested loop join. So starting to do a lot of these, let's put some things in a work file, and let's just go nested loop join, feed these values over, and hit the index on that outer table, or the main table that's in your query. Something that's become even more popular, especially when version 11 came around, is something called a sparse index. Okay, so we will see oftentimes now an in list that puts the values into a work file, but the work file is not always the starting table in a nested loop join. They put that work file, which is most likely going to be the smaller of the 2 tables, because you're just building a list, unless your list happens to be 850 million values in it. It's going to take that table, and you can see that the table name down here, this QB with a 02, and it puts it into what's called a sparse index. When it puts it into a sparse index, what we actually have going on here is like we have in LUW as a hash join. In hash joins, which we don't have on the mainframe, we have what's called a hybrid join. They don't have a hybrid join in LUW, but they have this hash join. And the hash joins have gotten more and more efficient in LUW over the last few versions. And they'll take the smaller of the 2 tables based on the where logic, and they'll place it into a file, hash those values in there, and then they'll do this hashing lookups from the starting table. So this is kind of interesting. We have a very small table here. It looks like about 106 rows are going to come out of this here, and it's going to build a sparse index on that, which is going to have the join column. Okay, the join column over here is going to be department number equals the the department number here equals the department number in this other table. Okay, that's our join column. And then any other columns that are going to be referenced from this other table, which is the project table. So the project, so what's going to be in here is the join columns and any other columns we need from that other table. Now, I have yet to see this, in my experience, cause any kind of performance issues. In fact, I talked to Terry Purcell one IDUG about this. Said, Terry, I'm starting to see a lot of sparse indexes, more and more. Is there anywhere, any time in your guys' testing you've seen that, that really didn't work out very good there? And if so, how would I not have the optimizer do it? And he said no. I said, okay, well, in my experience, I have not seen it either. So let it go ahead and optimizer do its thing here. Now, another area where we see sparse indexing a lot is on our table expressions. Here we have an example of this is coded up in the with clause called a common table expression. We could actually have coded that down in from, would have been then called a nested table expression. Okay. So these table expressions, when they get used in joins for many years, those table expressions would get put into a work file called materialization. And that work file then would get joined to whatever table we're joining it to. That work file would then not have any indexes on it. Well, kind of rule, join rule 101, when we're joining, columns in a table 1 to table 2, we should have indexes on both sides of those columns that we're joining on. So what would happen for many years is these work files that would get created out of these table expressions would not have any index on them. And it would default to a merge scan join. A merge scan, one of the reasons for a merge scan join is if one of the tables doesn't have an index, okay, on it. Now, does that mean if I have a table that doesn't have an index, it's always going to be a merge scan? No, but it is a reason where you might see a merge scan. Okay, and so we would, with these materialized work files based on these table expressions, we would most often see merge, scan, joins, or if it looked like it was going to be a small amount, it may be the starting table and a nested loop join. Well, now it just puts it into this sparse index and does this hash join between the two. Very good. Okay, safe query optimization. Let me go forward here, man. Let me go back. Okay, back up. Safe query optimization. So, you know, the optimizer in its costing, you know, it's got a lot of things to cost out. If I have some where logic, like right here, I have an index on department number, I have an index on employee number, and I have an index that begins with last name. It's a composite index, last name, first name, middle initial. So when the optimizer gets this, it's got to figure out, what am I going to do here? Do I use the department number index and then go check the other two columns, you know, from the row? Do I use the employee number index and then go check that? Do I use the last name index to grab all the last names between, then go compare the other two? Do I use a multi-index? Do I use two of them? Do I use three of them? Do I use none of the indexes? And it's going to cost all these out. Well, up until a couple versions ago, what it would do to choose an index would be the one where the predicates being applied to that index has what's called the lowest filter factor. A filter factor is a guesstimate from the optimizer that if I just execute this query, how many rows do I think I'm going to get back? Now, that becomes pretty tough when you have host variables involved. So there's hard-coded filter factors in the optimization code that, based on the table and the cardinality of the column involved, is going to come back with a very specific hard-coded filter factor to use. So let's say the filter factor for department numbers it was going to be like, say, 8% of the data, and employee number greater than was going to be like 9% of the data. And then the last name between this came up with maybe like 10% of the data. So what it would do for years, it would take the one that had the lowest filter factor that was either in a hard-coded situation or something that it calculated, and it would say, I'm definitely going to use that index. Well, that's not the case anymore. When it has multiple choices, and the filter factors on those predicates are pretty close. What do I mean by pretty close? I'm not sure exactly what the thresholds are there, but if they're pretty close to being about the same percentage or pretty close to that, it's going to pick the index that it thinks is safer. So what's safer here? I would say an in predicate is probably safer than a greater than. You don't really know what value is coming in. You know, so if it used the employee number greater than, if it used the employee number index, what happens if it comes in with a low value or a high value? Department number in, it's always going to have 5 values. So if those two are pretty close, but the employee number might have been less, it will pick the department number. So those of you that kind of get into this and look at the filter factors and such, you might go, wow, here's a case where one of the predicates filter factors was lower than the other one, but it didn't pick that index, or it didn't pick that table as the starting table in the join process. So the filter factors come into play a lot. Which index do I use? Which table order do I put the tables in? What the join type should be? Nested loop, merge, scan, hash join, hybrid join, you know, whatever platform you're on. Okay, index include. This is just a kind of a design thing that I thought was just great. We can include columns in a unique index, keep the columns that were already there as a unique definition. It doesn't change that, but we can then we can do this now without having to create another index with the same columns plus the 1 or 2 I want to include. Been very handy, because from the application side, and many of you probably know, that if we can ever get a query to do index only, the speed of the query is tremendously faster. You know, I've seen some that have gone from hours to seconds, and you guys have probably seen some big extremes like that too. So a lot of times we do on some really critical kind of queries, we want to get it to do index only, and we may change the definition of an index. Well, now we can do an include that many of you have seen before. That's been very helpful. Here's one from the application side that I thought was really good in version 10. So when we get -911s, we're locked out. My query, or one of my queries in my program, is trying to go after some data that somebody else has a lock on. And when I see that when DB2 sees that there's a lock called an exclusive lock, an exclusive lock is going to be an insert, an update, or a delete to a row, or that's going to have a lock on the page that a row is being updated on, depending on whether it's row or table, row or page level locking. Okay. So DB2 is going to take my query, and it's going to, I call it putting it in a queue, and it's going to keep checking that lock on that I'm trying to get to on the table until that lock goes away or an amount of time goes by that's set by one of the Z-parms. And if that amount of time goes by and there's still a lock, I get DB2 kicks me out of the queue and sends me back a -911 for my query. Says you're locked out. I tried to get you to the page. It's still being locked after a certain amount of time. Most of the amount of times that I see is either 30, 45 seconds, pretty typical. So you can, in dynamic queries, you can, in your prepare, in packages, you can do a bind option. And what this does is it alleviates me from getting a -911 if there's an exclusive lock on there due to a delete or due to an insert. If I go and I get a lock condition in the running of my query, and the exclusive lock on what I'm trying to get to is an update situation, I'm going to go through that queue and checking and the time and the whole bit. But you know what? There's a lot of times I don't care if there's a row being deleted or there's a row being inserted on there. So what happens if I go to get some data and there's a delete lock encountered? My query is going to bring that row back because that delete has not been committed yet. So at that point in time, that row was still valid. Now, maybe 3 seconds later, it got committed, but at that point in time, that row has really not been deleted yet. And what happens if somebody inserted a row on a page and the row that it inserted met my where criteria? That's going to put an exclusive lock on there. I go to get data off there. It says, oh, an exclusive lock. Oh, but it's an exclusive lock due to an insert. My query ignores the insert. So now I'm only going to get the -911s when there's an update exclusive lock. This is great. I've been in some situations where when we looked at the 911s going on off and on during a day, they were getting locked out from these little batch ads, jobs that were running throughout the day. So I don't want to get locked out if they're like just inserting some rows there or deleting some rows. So this can come in handy. Okay, and you know, when version 11 came along, it started when I was saying like indexable versus non-indexable predicates. The optimizer is now starting to rewrite some of the more common inefficient ways that developers write their predicates. Okay, you know, the year of a date is so common, even years and years ago with developers. I can't tell you how many developers and how many presentations I've given to groups like, stop it. Don't code this. This is bad. This is a non-indexable, and then it gets knocked down to a stage 2 predicate. You cannot get a worse performing predicate than coding this stuff up. And it's been that way for like 30 years, 35 plus years. But how many developers actually know that still today? Not enough from my standpoint. So we had rules and we had walkthroughs and we had standards and we had to educate the developers. Do not code this stuff this way. So finally, version 11, these are some conversations I remember having with Terry Purcell too about that. Gabe, what are you seeing out there? So, oh, I can tell you a lot of real common things I see, because they don't teach them this stuff when they teach SQL classes about the inefficiencies of the code at times. So let's take a look at some of these. Here's one, a little bit different kind of between, where you say where a value is between one column and a different column. Good example is this date value here is between a start and an end date. That gets rewritten like this, okay? That's something in documents that I've had on projects in the past. I had a list of predicates like I don't ever want to see a predicate coded this way. You code it this way or it's not going to production, because it is a non-indexable predicate, number one, and a lot of them fell into a stage 2 predicate. So there's one example there. Here's with the date of a timestamp column, another extremely common thing that developers do, still do today. But what happens is the optimizer code rewrites it like this. The same thing that we put in our documents for developers, don't code it this way. Great function, real simple, but don't code it that way. Now, do other optimizers do this? Does Oracle, SQL Server, Postgres, Maria, do all of those do that? No, they don't. Do they do some of them? Yeah, I don't know ins and outs of every one of them. But in general SQL programming practice, developers just need to learn, do not put functions on your columns in your where logic. DB2 is covering for you the other relational databases. I can't speak for all of them. My guess is many of them do not, okay? The year of a date should be coded like this. Cover your whole 1/1 to 12/31 days of the year. That gets rewritten automatically, and you'll see that in the explain output. So what the year of a hire date, which is a non-indexable stage 2 predicate, actually gets rewritten to an indexable stage 1 predicate. So it goes from the worst to the best. The optimizer is rewriting that. Okay. Case logic. Case logic in general is kind of a flag to me when people are using case logic. Even if you have case logic up in the select, it's much more expensive than some of the built-in functions, and it's going to be as expensive as however many rows come back. And it's nice to have, and sometimes we need it. But sometimes we may be able to get away from it. If I have case logic down in the where clause, it used to always be non-efficient. But if my case logic can be evaluated before my actual query takes off, when we're putting case logic against a host variable, then that can be very efficient and can be indexable based on the predicate that it's part of. That's a good thing. Predicate pushdown, those are write table expressions. I think, I know I've seen this a lot before, where the table expression here, okay, this is called a nested table expression. This could easily be moved up into a with clause called a common table expression. If there's a sort that's going to take place within here, this is going to get materialized into a work file. Well, we shouldn't then have predicates against that work file to eliminate certain rows from there. I mean, why would I want to put rows in a table and then eliminate some of them from my result set? So this code down here gets pushed up into the table expression definition. Now, do all table expressions get materialized? The answer is no, they don't. How do I know if they're materialized? You'll know if they're materialized if you see a work file table name that you call it here. This one's called temp. If I see temp as a table name in my explain output, then we know it was materialized. If I do not see the temp table name here, then it did not get materialized. And that's kind of a good thing, an interesting thing to know. I'd like to know if my table expressions are getting materialized or not, because there's some overhead in the materialization. But the overhead can offset some other ways that we could write the query. So sometimes we've taken some queries and rewritten them with table expressions. We saw the materialization, but it was so much faster still than the way it was before. Okay, now we're seeing with these table expressions, when they get materialized, oftentimes there's that sparse index is putting on there to make it even more efficient. So it takes some kind of sort or some kind of special function for things to kind of get put together and the function and gets applied. You know, like statistical functions are pretty common. Or some kind of sort due to a group by or an order by or distinct or something, and that will materialize that output. Or logic, okay. This was something that always like raised some eyebrows to me. It's like, okay, you have a column that's defined as null, and you're oftentimes looking for a value or knowing when it's a null. Is there a problem if we just let it be spaces or zeros? Does null mean something different than spaces or zeros? Because if it does not mean anything different than spaces or zeros, why do we have it defined as null? Because when you have it defined as null with something like this, then developers have to code this kind of stuff all the time. I want to see where it's a value or it's null. We always have this or is null logic. And for many years, decades, that was extremely inefficient. So whenever I saw code like this, I would go and do some evaluation. That's when I would go and talk to a DBA. Does this thing have to be null? Maybe we can change this, and we'll change all the ones that are null to zeros or spaces. And if so, then we can take all this or logic out of there that's not being very efficient from the optimizer. So as of version 11, it can choose multi-index access, and what it does oftentimes is it rewrites it as it puts null in the in list. And we might see that put into a work file and then used in a table join. So it's handling this a little bit more efficient. But this is one of the things that in discussions, like, no, this is I see this out there time and time and time again. Where so often there's columns that are defined as null in tables that don't need to be null. From a developer and a performance, it's much better just to let them default to spaces and zeros. Dates sometimes are a little bit different discussion, but okay. Another thing is, again, if we had or logic here with an in predicate prior to version 11, we're not choose multi-index access. Now we can start seeing multi-index access. So the distinct has gotten a little bit more efficient. The distinct does not always cause a sort. And the distinct now, when we're distincting with a join like this, it's going to execute just like a correlated subquery. A correlated subquery like exists logic, it says, like, for example, does this employee number exist down on this other table? Well, even if it exists down on that other table 400,000 times, it doesn't go check all 400,000. It sees that it's in an index there, could have 400,000 ribs associated with it, but it comes right back and says, yes, it does exist down there, and you don't get the duplicates. Now, if I did a two-table join, we would get the duplicate rows coming out. So what do developers do 99% of the time when they get duplicates out of a join? They throw the word distinct in there. The distincts oftentimes causes sorts, okay, to put things in order. Okay, well, one of the improvements now with the distinct is it will not, if what we're distincting on, okay, here, comes from one table, so we're not pulling anything from the other table, the EPA table, there's no data being put up into here. The distinct oftentimes now will not cause the sort, and we'll see that in the explain output. Whereas before, it would oftentimes create the sort. Okay, 1 second, please. Hey, I'll be with you in 1 minute. Okay, don't knock on the door. Okay. And just another kind of thing for developers, you know, this has been around for a little while. Version 9, maybe this came out. All right outer joins are always rewritten as left joins. And if you use any query tool, like Data Studio, for example, you can see the query transformations. That's one of the things I like about the Data Studio tool is I can go in and see the transformations. You know, some of these things that get rewritten by the optimizer, I can go see. If I'm looking at an explain that looks confusing to me, I go, I want to go see what the optimizer did with my query. And you'll see the rewrites in there, which is an awesome thing. It's something that many of us wanted to see like 20 years ago. Right joins are always rewritten as left joins. So why do we have right joins? Well, because Oracle and Sybase and some of them had right joins years ago. Why do they have right joins? I'm not quite sure exactly why. But we know there's never a reason why we need to code a right join over a left join. Never. There's no logical time where that we go, oh, you have to do a right join there. No, we know that, and the optimizer code knows that, so it just rewrites it as a left outer join. Because it's got left outer join logic already built into its processing code. If I have an outer join and I have some where logic on what I call the null, what they call the null supplying table. When you write outer joins, the first table is the driver table, the second table is the null supplying table. Because when you send a value over there and it doesn't exist, anything that I reference up here in my select is going to come back as null. But once I put some logic on a column in what's called the null supplying table, it's not an outer join anymore. You're saying like, oh, I don't want the exceptions. I don't want the cases where something's not found. I only want the case where it's found and a column on that found row happens to be, in this case, a job equal analyst. So it gets rewritten as an inner join. This is very confusing to a lot of developers because they see left join, but they never see any exceptions come out. Well, you're not going to get any exceptions once you put where logic on the null supplying table. So the optimizer is smart enough, like, no, we'll just rewrite that as an inner join because that's really what's going on here. Okay, so that's a little bit of my favorites. From the Thema side, you know, obviously we do mostly training. We do consulting also, but these on our website, themasync.com, these are the classes that really kind of fit into some performance and tuning, kind of related to the topic that I was talking about here today. You know, the SQ1010, by the way, is one of our most popular SQL classes. 5-day class, gets really involved in some good heavy logic, and people come out of there like much stronger. And of course, all of our different optimization, performance, and tuning classes. Just about every one of them hits some on application, some hit a lot on application, and the 3052 hits on application and a lot of things on the system side, even in the buffer pools. So some different choices there. Education, hey, I have a book I wrote a number of years ago. IBM Press has only taken this up to version 10 and decided not to start publishing as many books anymore. But it's still a great read for like developers. It has all those tips in there as far as what to write, what not to write, and all the different situations. It's been a good book for me. And of course, themasync.com. We got classes, and not just DB2, a lot of the other platforms also. A lot of hands-on coming from Themis. You come to a Themis class, guaranteed you're going to be coding and doing some workshops, explaining whatever it might be. So I thank you all for attending. Thank you, Martin, for the invite and being part of the DB2Night show. And everybody have a great weekend.
Thanks, Tony. That's great, and thanks for that information on Themis. As you know, I also teach for Themis. I teach the DB2 LUW DBA class and the system performance class as well. I've just finished the DBA class, and I've got a system performance class scheduled for one customer in the fall myself. So it's all good information. and Themis has been doing a great job. So with that, let me take back control to ask our final question here. Just have to find where that is. Here we are. Always click the wrong button first. You know, the correct button is always the one I click last. All right, let's move that along then. We'll get on to our next screen, which is our final screen, and our final polling question, which is always, did you learn something today? We always like to ask this question. We always get good answers to this, which is great. We'll close that off and share the result. And 100% of our audience learned something today, Tony. You did it again.
That's good to hear for sure.
That's what you call good feedback. We appreciate your time and effort, all the things you put into doing this for us and the DB2 community. We're always grateful for your time and your expertise, and we look forward to having you back perhaps next year when we set up our schedule for the for 2021 in the fall and 22 in the spring. So
certainly, I'll take your invite anytime. Thank you.
Thank you. All right, now let me at this point cue the music. Turn up the volume a little bit so you can all hear it. And again, I'd like to thank everyone for coming along today on our final show of the 12th or 13th season of the DB2Night show. And we'll see you in September. Have a great summer. Be safe and be healthy. And we'll see you back in the new year or in the new season. Bye-bye. Thanks again, Tony.
Yep. Thank you.